Sorry about that. I guess my video got cut off there a little bit, so we get back to these examples. So to take something like 1 plus I in rectangular form and put it into polar form, um, again, we got to find our R value. So to find our R value, we just use the Pythagorean theorem, A squared, A and B. So 1, and then the B value here would also be 1. So 1 squared, 1 squared, 1 squared is 1, 1 plus 1 would be 2. So my R value is going to be the square root of 2. Okay. Now, when you go to find the angle, it is important to keep track of what quadrant you'd be in. And we know we're in quadrant 1 because we go right 1 and then up 1. Okay, so we're looking for an angle in the first quadrant. So the way we find the angle would be, again, the inverse tangent. Okay, inverse tangent of B over A, so 1 over 1. When does tangent equal 1? Well, we know that's a 45-degree angle, right? And again, we're in the first quadrant. Technically, it's first or third, right? But we know we're in the first quadrant, so we can kind of ignore that third quadrant here. So our angle is 45 degrees, which means our answer would be the square root of 2 times the quantity of cosine of 45 degrees plus I sine of 45 degrees. Okay. Now, that is the correct answer. Again, but we could use that shorthand version, which would be the square root of 2 CIS 45. Okay. So either one of those two answers would be sufficient. Let's try another one over here. Again, important to keep quadrant in mind here. So we'd be going right 1, down the square root of 3. So somewhere down here, right? So we're looking fourth quadrant. Okay. Again, we'd want to find our R value. So our R value would be A squared plus B squared. So 1 squared plus negative square root of 3 squared. Square root of 3 squared is 3. 3 plus 1 is 4. Square root of 4 would be 2. Okay, so our R value here is 2. And then again, we go to find the angle, and we do the inverse tangent of the B value over the A value. So when does tangent equal the square root of 3? Well, we know from our table, tangent's equal to the square root of 3, 60-degree angle, right? Well, negative in the second and the fourth quadrant. We know we want to be in the fourth quadrant, so we need a 60-degree in the fourth quadrant, which would be 300. So our theta, our angle, is 300 degrees. And yeah, you could use negative 60 as well, but 300, it's more, looks better to stay positive. So our answer would be 2 times the quantity of cosine of 300 plus I sine of 300. Or, shorthand version, 2 CIS 300. Okay. Let's try a couple going the other way. So what if you're given something like 3 CIS 45, a polar imaginary number, and you have to put it into rectangular? Well, knowing what this means is really most of the battle. Knowing that this really means 3 times the quantity of cosine of 45 plus I sine of 45. And then all you really have to do is calculate it. You know, you got to figure out, well, cosine of 45. Use our table. We know cosine of 45 is root 2 over 2. Plus I sine of 45 is also root 2 over 2. And then distribute. 3 times root 2 over 2 would be 3 root 2 over 2. Plus, that would be 3I root 2 over 2. And you're done, because that's in rectangular polar number. This is an A plus BI form, right? So that's all you have to do. So going the other way is even easier, where all you have to do is really calculate this out. 3 CIS 300 or 4 CIS 300 would be the same as 4 times the quantity of cosine of 300 plus I sine of 300. Using our table, 300 degrees, 60-degree reference angle, fourth quadrant, right? So cosine of 60 degrees, I'll give you a second to think about it. Cosine of 60 degrees would be 1/2 plus I sine of 60 degrees would be square root of 3 over 2. Now, quadrant, got to make sure you pay attention. Cosine's positive in the fourth quadrant. Sine would be negative, so this should be a minus. We've got to put our I in there. And all you got to do is distribute the 4. 4 times a half would be 2. Minus the 4 and the 2 would reduce to 2I root 3. All right, so give a few a try. I will talk to you guys later. Thanks.